Have a look!
And now, we will show you the features of Fuji Seimitsu's fine U-nut. The fine U-nut is a lock nut for use with bearings that applies the basic principles of the Fuji lock U-nut. As with the Fuji lock U-nut, the friction ring is integrated with the top face of the nut. Additionally, the stress and reaction force that is produced with the screw threads creates a structure that prevents free rotation. Now we will introduce the features that make the fine U-nut a groundbreaking nut for use with bearings. First, the machining of keyways that was required on shafts until now is unnecessary. And since no lock washer is required, there is no possibility of its incorrect installation.
Click!
Significant labor saving in work processes and simplified assembly can be achieved.
Click!
In addition, workability and functionality are both excellent, as assembly does not require a high degree of skill. Fine adjustment is possible from any position, and torque management is also easy.
Click!
Use of the fine U-nut also improves rotational balance of the shaft. In addition, it is possible to use hollow shafts that are thinner than normal for weight saving.
Click!
Reusing the nut is also possible, which reduces invisible costs and helps achieve a total cost reduction. Now we will explain the basic specifications of the fine U-nut. The shape consists of a grooved round nut with a 270-degree integrated friction ring. The lineup of sizes includes M8 to M100 for the SS series, M10 to M150 for the SC series, and M10 to M100 for the SUS series. Thread accuracy conforms to the JIS 6H standard, and extra fine thread pitch is available. The maximum face runout is 0.05 millimeters for sizes M8 to M50, 0.07 millimeters for sizes M55 to M120, and 0.10 millimeters for sizes M125 to M150. Various materials are provided for various shaft types, and Lubrite treatment is available as a surface treatment. Now let's look at experimental data that shows the excellent performance of the fine U-nut. First, we'll measure the frictional torque, called the prevailing torque, that is produced by the fine U-nut friction ring strongly placing stress against the shaft screw threads through a spring effect. As shown in this graph, prevailing torque increases as the nominal diameter of the nut increases. Even if nut removal and installation are repeated for 10 cycles, the prevailing torque is hardly reduced. By looking at this, you can see how free rotation is prevented through stable prevailing torque, and how the fine U-nut can withstand repeated use.
Excellent!
Next, let's look at an actual test video to really understand the quality of the fine U-nut's locking function. The first type of test is an axial impact vibration test. In this experiment, an ordinary nut with a lock washer and a fine U-nut are compared. To achieve stable test conditions, a preset type torque wrench is used, and the shafts and nuts are set on a vibrating barrel. An axial impact vibration is then repeatedly applied to the shaft and nut on the testing unit. After 13 minutes, the ordinary nut has come off and the lock washer is broken. the fine U-nut is still tightly locked. Have a look at the results. The locking function of the fine U-nut is maintained even after 60 minutes. The next experiment is a rotational durability test using this rotation test unit. The nut is fastened to the shaft, and forward rotation, reverse rotation, sudden acceleration, and sudden stopping are repeatedly performed. Inertial force is applied to the nut itself, and the locking of the nut is judged. With an ordinary nut, the lock washer breaks after about 110,000 cycles, and the nut comes off. In comparison, the fine U-nut is completely unchanged after 500,000 cycles. You can see the results of the rotational durability test here. As you can see, the excellent locking performance of the fine U-nut can be verified in all kinds of tests.
It's definitely the best.
Installation of the fine U-nut is easy.
It's easy.
Apply lubricant after checking that the tip of the thread portion of the shaft has a chamfer that is equivalent to the distance of 1 pitch. Manually screw the nut on until the friction ring touches the tip of the threaded portion of the shaft. Check that the friction ring is touching the thread portion. Use a tightening tool made especially for the fine U-nut. You may use a hook wrench instead. Press down on the axis portion of the ratchet handle and tighten by lightly turning the ratchet. Check that the bearing's inner ring and the fine U-nut bearing surface are in complete contact with each other, and that 2 full shaft threads protrude beyond the friction ring at the top of the nut. For convenient installation of the fine U-nut, use Fuji Seimitsu's customized tightening tool. The fine U-nut tool set 0010 is for sizes M10 to M50. The tool set includes sockets, a ratchet handle, an extension bar, and a steel case. For sizes M55 to M100, an FUT socket and handle are available for each size. Lastly, we will review the precautions for using the fine U-nut. The thread portion tip should have a chamfer equivalent to the distance of 1 pitch, and the thread accuracy should be JIS 6G. Use lubricant when installing and removing a nut. When the shaft has low hardness, use lubricant with especially high lubricating properties. For full locking, ensure that 2 full shaft threads protrude beyond the friction ring at the top of the fine U-nut. Face runout values listed in the size table are valid only for when tightening is performed to at least twice the prevailing torque. High-speed rotation impact wrenches cannot be used. The nut cannot be used if the shaft thread is machined with a keyway or other processing. The nut cannot be installed from the friction ring side. Stop using the nut if excessive deformation or any other fault is found on the friction ring or the clamp. Before use under severe conditions or with low axial tension, consult with Fuji Seimitsu.